Hello everyone, welcome back. So last class we discussed about the terminating and non-terminating, and now we are going to discuss very important topic, that is proving irrationality. So in the irrational number and rational number, so the difference between the rational and irrational already we discussed and we understand very well. I hope you have remembered. So irrational number which is under root of n, and where it is n is a not perfect square. Now perfect square means like 4, 9, 16, okay, like this. So except these, any other number, so you can take under root of 2, under root of 3, under root of 5, under root of 7, under root of 11, 10, whatever, okay. So except the perfect squares, so the remaining all we can take them as irrational numbers. But what he is asking here, we have to show the proof. So where in the exam, SSC exam, it is compulsory question since whenever it is introduced. So the proving irrationality is one of the important question, and there is no doubt at all, and we cannot expect the question paper without of this question. So I just divided these three types of the questions. So if you understand three types, definitely you can score around 4 to 6 marks. So please today let me continue the type 1 question. Okay guys, so I hope you are ready to listen, please. Okay, type 1. So type 1, so let us take one example. Prove that under root 3 is an irrational number. So already we know that that is an irrational number. Okay, but what we do, we should do that proof we required. So to prove that, we cannot go through the direct method, so we can go to the indirect, that is nothing but by contradiction method. Okay, right. So by contradiction method, we can take now it is an irrational number, but let me take now that is as rational number. For example, now root 3 is a rational number. Root 3 is a rational number. Once it is rational number, what is a rational number form? Generally a by b, where a and b are co-primes. A and b are co-primes. What is the meaning of co-primes? Co-primes, there is no common factors except 1. So the co-primes does not have any common factors, okay, except 1. Right. Now root 3 is equal to a by b. Why we have taken a by b? Because we are assumed that root 3 is a rational number. Once we assume the root 3 is a rational number, root 3, so square root, how to remove the square root? We know very well, to remove the square root we have to do the squaring on both sides. So let us squaring on both sides. So let us do the squaring on both sides. So square root cancel. Now 3 is equal to a square by b square. Here very simple, just let me transpose. Okay, 3 by 1 nothing but, so the b square is equal to a square by 3. A square by 3. So a square by b square comes here, 3 goes here, 1 into a square by 3. So b square is equal to a square by 3. Here we have to be important note. What is that? A square is divisible by 3, then automatically a is also divisible by 3. That is very important statement. So what we are writing here? A square is divisible by 3, then a is also divisible by 3. So very simple, all problems, same procedure, same steps. Only some small change would be there. I would explain you that. Please listen here. Only a square is divisible by 3, then a is also divisible by 3. Now let us take when a is divisible by 3 means, so a is nothing but multiple of 3. So we can take a is equal to 3k. So let me substitute in this. So b square is equal to 3k by 3 here whole square. So the b square is equal to 3 square. So 3k square is nothing but 9k square by 3. So 3 ones are and 3 threes are 9. The next 3 comes here, 3 comes to this side. So that k square is equal to b square by 3. So let's transpose these 3 to the LHS. Okay guys? So 3 transpose to here. Therefore b square by 3. Now what do you say? B square is divisible by 3, then b is also divisible by 3. Here observe here, the first a square is divisible by 3 means a is also divisible by 3. b square is divisible by 3 means then b is also divisible by 3. So please observe here, divisible by 3, divisible by 3. But what we assumed here, a and b are co-primes. Co-primes means there is no common factor. But what we are getting here, they are having that 3 is a common factor. So here what do we write? A and b are having 3 as common factor. Common factor. So our assumption is right? No, absolutely our assumption is wrong. Why it is wrong means here what we assume a is equal to a by b, then a and b are the co-primes. Co-primes does not have any common factor except 1, but here it is showing that 3 is a common factor. So our assumption is wrong. Then what is right? The right is our assumption is wrong. Then what is right? The right is under root 3 is an irrational. Under root 3 is an irrational. Guys, please once understand here. He will ask you the question, prove that under root 3, under root 5, under root 7, under root 2, under root 11, nothing, anything we can ask. So that by contradiction method, because we are going in the opposite method, nothing but it is. If it is not, then what? If it is not, then what? So if it is not means by contradiction method, what we are taking, it is a rational number. He is asking to prove the irrational number, but we are taking it as a rational number. The rational number, it is in the form of a by b, where a and b are the co-primes. Co-primes means does not have any common factor. So that now we are getting here 3 is a common factor. So that it is our assumption is wrong. So then our assumption is wrong means what is our assumption? It is a rational number. Then our rational number is wrong means what is right? Irrational number. That's it. So under root 3 is an irrational number. So that please step by step you do. Under root 3 is equal to a by b squaring. On both sides square root can be removed by the squaring. So b square is equal to a square by 3. So a is divisible. So this is a procedure. If you understand, if you follow, you will get more problems. So I will give you few examples. So do the practice. So these two problems, just solve them neatly and send to me. Okay. So what are those? Under root of 5 and under root of 7. So under root of 5 and under root of 7. Just you have to change the place of 3. You have to write 5. Just in the place of 3, you have to write 7. And remaining step as it is. Okay, guys. Right. I hope you understand. And so type 2 and type 3 will be continued in the next class. All the best.